During yesterday's pops, I realized that I was still a bit afraid of bits of capacitor flying out and hitting the cameras or me, so I held back a bit. In fact, I held back quite a lot. So they weren't that exciting. The film capacitor gave some interesting jets of flame, but I probably could have gotten a lot more exciting blasts out of it had I actually cranked it up. But no! An unsuspecting wine box has wandered into my workshop and immediately been repurposed into a temporary blast enclosure. Not going to be blowing up anything big, but this will at least contain small caps and other bits that would otherwise go flying off in random directions. Painted the inside black to provide high contrast, and in order to actually light up the subject, let's say that this little bit of cardboard and paper towel is a cap with some smoke jetting out of it. I decided to get some lights in here. These are old track lights. I connected them up to just a plug. And there's some light. So it's now lit up, and it has a high contrast background. The final component needed before I feel fully comfortable cranking things all the way up would be some sort of blast shield for the cameras and hopefully me as well. I considered a few old aquariums I had lying around, but they're scratched and smudged, and even with lots of scrubbing and cleaning, they're not very clear, so they would mess with the image quality a bit. However, the microwave I recently acquired and have started to take apart for the goodies inside has a door, and microwave doors usually have decently thick tempered glass like this. This is about 3/16 of an inch thick. If I put that down like so, suddenly there's a shield covering the entire opening, so that even little bits pointed towards glass will just bounce off. If I zoom in a sec, I can probably get some test footage. Here's an example shot with the high-speed secondary camera. And here's an example shot with the main camera. Another reason why I was a bit reluctant to crank everything up the other day was I'd recently added capacitors to the rectifier assembly here. I added the pair of 560 microfarad capacitors from the high-pro power supply, there in the center, and I also added a pair of 470 microfarad capacitors from a washing machine motor controller. The capacitors from the motor controller hadn't been run at anywhere near full voltage for many years, so I was reluctant to take them all the way up. Tonight, I've spent a few hours cranking it up very, very slowly, making sure everything will sit at the full 400 volts output, and not complain about it. Variac is fine, capacitors are fine, the balancing resistors are also fine despite the extra leakage of the added capacitors. The issue with electrolytics in series is that the leakage current from upstream capacitors, if greater than the leakage current of downstream ones, can cause the downstream ones to overcharge and eventually fail. So these resistors force the capacitors to have exactly the same voltage, 200-200. This now has 1015 microfarads at up to 400 volts for about 82 joules of stored energy. Thanks for watching.